Okay, so we're going to keep on rolling into not parametric, polar coordinates, and this is going to be a new way to kind of think about a coordinate system. Usually we think of x's and y values, but now we're going to think about this in a different way with r's and thetas. So what our r is going to be is the directed distance from O to P. So another way that we can think about this is as a magnitude. So it's just the distance of that line. It's the magnitude of that line from the 2 points. And then what theta is going to be is the angle. So all we're going to get is an angle and a direction. And if we start at one point and we're working in a two-dimensional field, so all we can do is turn, right? All we can do is turn and move. So this is an accurate and pretty easy way to describe lines, to describe coordinates this way, because if I know that I have 1 point on this plane, this flat plane right there, I can say here's the direction, and it's this far that way, and you're right there. So this is just a new way of describing coordinates. As I said, r is going to be the directed distance from O to P, and theta is going to be the directed angle counterclockwise from polar axis to segment. You don't have to think too hard about this. Theta is just going to be the direction like on the unit circle. So the coordinate system isn't going to change at all. Might be a little difficult to remember, but it's nothing that you haven't seen before. We'll notice here that 0 is 0, 90 degrees is pi over 2 like it is on the unit circle, 180 degrees is pi like it is on the unit circle, and so on. So it's not new information. Just like last section, it's just taking the information we know and applying it differently. And I almost forgot to fill this in right here. In this section, we will study a different system called the polar coordinate system. To form the blank coordinate system, you might be able to guess that it is polar. So to form the polar coordinate system in the plane, fix a point O called the pole, or the origin, and construct from O an initial ray with magnitude r called the polar axis, as shown in figure 10.59, which I believe is this one. So P equals r theta. So instead of xy, we're going to have magnitude direction, and theta is going to equal our directed angle. And so I'm going to go over one of these examples quick. I will graph one of these, and then I will add a picture for y'all to add some more. So the point r theta equals 2 pi over 3. Well, what I like to do is count the rings first. So I know that it's not going to be the first ring. It's going to be the second ring, right? Because that's our magnitude. So these circles represent the magnitude. So if you travel any direction, 1 unit, it's going to be on this line, right? Or any directions 2 units. So we know that we're going to be on this 2-unit circle, and we're going to be at pi over 3. And it's pretty easy to do when the coordinates are all laid out for you. But pi over 3, we can think of that as 180 over 3 is 60. So 60 degrees is going to be right here on the second circle. There is our point. And so, like I said, I'll put a picture of this on another slide, and I want y'all to graph points B and C on that picture, and we'll talk more about this in class.